This is Geometry Semester 2. This is a rigid motions review. It's unit number 11 actually, and it's the second lesson within that called Rotations, Dilations, etc. Practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find the site. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Make sure you are finding the website. This might help a little. If you go to creatormath.weebly.com, it'll help you find that. The home page looks like this. Go to the Geometry tab to find all of the lessons, all of the notes, and all of the video lessons, and all of the problem sets. Pass by the vocabulary, that's up first here. That'll help you move through your vocabulary practices. It's semester 2. Table of contents, it goes on pages 2 through 6 of your composition book. That should be copied in there a long time ago. If not, copy in all these items. And let's go down and find the rigid motion review. It's way down here, number 11. So right here, rigid motion review, it looks like this one, number 2. Rotations, dilations, stretching page here is where it goes in your composition book. Please check the actual table of contents when you're doing this, not this video, because this will be changed by then. The notes will be posted here under notes. The problems are the ones we're looking at are posted here, and the video solution will be posted there. So let's see here. What are they asking us to do? Given the following points, if they're plotted to form a triangle ABC, if rotated clockwise 90 degrees about the origin, the new point C will be. So I am going to plot these points. Let me see if I can make this a little bit cleaner this time. Negative 9, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2. This is A, and it's negative 9, comma 2. B is negative 2, 1, 2, 2. This is B, negative 2, comma 2. C is negative 2, 7, 2, 3, 4, 5, 6, 7. Getting a little bit in the weeds here. This is C, and it's negative 2, comma 7. And if you connect these, we get a right triangle. I know it's a right triangle because this line is horizontal, this line's vertical. And this would be our hypotenuse, so that would be the right triangle. So they're asking us to rotate clockwise 90 degrees about the origin. Where's the new point C? So C is up here. So first of all, clockwise, if you remember the old school wheel clocks, the hand clock, which a lot of my students do not use anymore, so the word clockwise often presents a problem. If this is the hands on an old clock, clockwise goes this way, right? Rotates to the right, I call it. And counterclockwise would be to the left. So we're rotating this point. So let's see how far it is. 1, 2, 3, 4, 5, 6, 7 up. So 1, 2, 3, 4, 5, 6, 7. It's 2 away from the axis. So it's going to be out 7, 2. This point is going to rotate to here. Well, I don't like that all of a sudden. Nope, I don't think it's going to rotate there. It's going to rotate to, let's see, rotate 90 degrees. 90 degrees is into the next quadrant. Here we go. We're on quadrant 2. We're going to quadrant 1. This one's going to go here. And this one's going to go up here. So we're going to go 2 out and 9 up. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up here. This one's going to turn into 2, comma 9. And this one's going to turn into 7, comma 2. Okay, there we go. 1, 2, 3, 4, 5, 6, 7, 2. Okay, and this one's going to rotate here and turn into 2, 2, right here. And notice we're dropping one of the signs and reversing the 2 digits, the X and the Y, and we're going to end up like this, rotated at 90. And it's going to go like stand up, right? It's going to stand up this way as it rotates. So our point C is going from here to here. So we're going to 1, 2, 3, 4, 5, 6, 7, 2. 7, comma 2. And notice the sign changed. We switch places and one of the sign changes, right? And that's the way it happens every time. And it's better just to map it out. 7, 2 is right here. All right. let's go to the next one. They're going to take the same thing. They're going to say, given the same point, so we don't have to redraw it, if rotated counterclockwise about the origin, the new point C will be. So this is now going to rotate down to here. So we're going to rotate this way now, counterclockwise 90 degrees. This one's going to end up at 2, 2 again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's make sure we got some numbers in there, some tick marks. B is going to go to here to be -2, comma, -2. It's going to be B prime in this case, or maybe double prime we'll call it. This one's going to rotate down. It's 1, 2, 3, 4, 5 away. 1, 2, 3, 4, 5 right here. And this one's going to rotate all the way down to -9 and 2 away right here. The 90 is going to be here, and the hypotenuse is going to be out here. So this would be A double prime here. If rotated counterclockwise, C would be. So this is going to be C here. Let's call it double prime. And this one's going to be -1, 2, 3, 4, 5, 6, 7. So -7, comma, -2. Again, reversing and reversing one of the signs. So -7, -2, and there we go, right there. -7, -2. And the rotation takes a little bit longer than translation and reflection. Given the points, again, the same thing. If rotated clockwise, 180 degrees about the origin, the new point B will be. So now we're going to rotate all the way around into this quadrant here. And it doesn't matter if you go counter or clockwise. If it's 180 degrees, you're going to end up in the same place, right? So we're going to have this point here is going to be at 2, -2. And we are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. The 90 is now here. So which point are they looking for? They are looking for point B. B is here. B is going to be at 2, -2. And it could be B triple prime at this point. So 2, -2. 2, -2. All right, so now we have this thing in all, we've gone to all quadrants one way or another, right? We rotated 90 degrees in the clockwise direction, we rotated 90 in the counterclockwise, and we rotated 180 degrees, doesn't matter which way. If you go clockwise, it's here. If you go counterclockwise, it's here. It's going to end up in that quadrant across from it. Given the following graph, if the original is on the left, this is the original, identify the rigid motion. So it looks like we are rotating to the right, which is clockwise, 90 degrees, and it is a rotation. So all they want right here is rotation. They want to know about what point, and if they don't specify, like this was not specified, so we are always going to assume the origin if they don't specify. Right? Most rotations in high school, a lot of times about the origins, just comes out a lot easier, and we need maybe better tools to find this than just the naked eye if we're going to do too complicated of rigid motion. So it's rotating about the origin, and I would call it the point of rotation. That's good. Let's see what's next. Given the following graph, if the original is on the left, this is the original, identify the rigid motion. Well, it's a rotation, and just as soon as I said it's always about the origin, this is not. Okay, so it is a rotation, and right here we have what is the point of rotation. So I think it's right here because it looks like this is literally pivoting on that right foot. So the lower right toe of the stick figure is my best option. If it were the origin here, this thing would be over here somewhere, right? Be a little bit further away. The fact that it's still touching toe to toe right there means that that is my point of rotation for this example. Given the following rotation, if the origin is on the left, what is the direction of rotation? This is the original. What is the direction of the rotation? Oh, they just want clockwise. Clockwise. Again, try to imagine, I don't even know if we have them anymore these days, right? Imagine even clocks in schools on the wall are digital nowadays. So the hands move to the right, that's clockwise, and this is moving to the right, therefore it's a clockwise motion. We still use clockwise and counterclockwise though, as far as I know. Given the following rotation, if the original is on the left, what is the direction of rotation? This one's going this way, this is clockwise also, right? Moving to the right. So this is a review lesson, not too long, but make sure you're lining up with the proper lesson that it is. It's Geometry, Semester 2. It is a rigid motions review, unit number 11 for the second semester, and it is lesson number 2, rotations, dilations, etc. practice. And it is on creatormath.com under the Geometry tab. So I hope that helps.